All right, so we have another question based on graph, which says the velocity time graphs of a car and a scooter are given. Car and a scooter are given. Find the difference between the distance traveled by the car and the scooter in 15 seconds and the time at which the car will catch up with the scooter. All right, so what we need to primarily understand here is the concept behind the graph here, which is velocity is equal to d by dt of x. Okay, so what is v into dt is equal to? V into dt is equal to dx. I'll write it down once again. V into dt is equal to dx. Now we integrate on both sides. If you integrate on both sides with limit 0 to t v dt and limit x1 to x2 dx, what is integral dx? Integral dx is x, so x varying from x1 to x2. Now what is x varying from x1 to x2? It is x2 minus x1. Okay, now when we have x2 minus x1, what is this meaning? This is the difference in the position at time t minus position t and position at time t is equal to 0. Now what is that basically equal to? That is basically equal to the distance moved. That is equal to the distance moved where distance moved in time t. Okay, so that's about the RHS. Now what about the LHS? See, integral t 0 to t v dt. Say for example, if this is the graph, right, this is velocity on the y-axis, time on the x-axis, and if this is the graph, what we need to understand is this. If this is from 0 to t, then integral 0 to t means this much of area under the graph from 0 to t. Okay, from 0 to t. Now, so 0 to t v dt means area under the graph from 0 to t. So the conclusion here is that area under the graph from 0 to t will give you the distance moved in time t. I repeat, area under the graph from 0 to t will give you the distance moved in time t. Alright. Now, what I'll do is, so if you have understood the previous explanation, we can now, using the same idea, we can calculate the area under the graph for these two bodies, which is car and scooter individually now. Okay, how do we do that? See, area under the graph of car from t is equal to 0 to t is equal to 15 will give you the what? Will give the distance moved by the car, right? Will give the distance moved by the car in t is equal to 0 to t is equal to 15. Which means, what is area under the graph for this curve? See, this is the curve here, right? This is the curve for the graph. Curve for the car. And up to t is equal to 15, this much is the area under the curve, right? This highlighted region is the area under the curve. So we can say that area under the graph is basically area. So this is OAC. So say area OAC is equal to distance moved by the car, which I write it as distance moved by the car in t is equal to 15 seconds. Okay. Now, What is area OAC? See, area OAC is basically equal to area of triangle OAC from the figure directly, right? So OAC is basically a triangle, a right angle triangle. Now what is the area of right angle triangle? Is half into OC into AC, right? So this much distance is OC. From the graph it is 15, right? So this is half into 15 into how much is AC? So AC from the figure is this much of distance, which is equal to 45. So we can write here into 45, right? So what is this equal to? Distance moved by the car in 15. T is equal to 15. Now 45 into 15. It's 45 into 15, 5, 5, 25, 5 was 20 plus 2 is 22, 5 is 5, 4, so we get 6, 7, 5. Then we have 675 by 2, which gives us 2, 3, 2, 3, 6, 675 by 2, 2, 3, 6. Then is 7, again is 3 to 6, 15, 7 is 14, 307.5. Okay, so what we get is distance moved by the car is 337.5 meters. So this is one part of the answer. Distance moved by the car is 337.5 meters. It would be better if you just highlight it. So distance moved by the car is 337.5 meters. Okay. Now let us use the same idea to find the area under the to find the distance moved by the scooter. And how do we do that? The only difference here is area under the graph of car from t is equal to 0 to 15 will be replaced by area under the graph of scooter will be equal to distance moved by the scooter in t is equal to 0 to t is equal to 15. Now, what is area under the graph here? See, area under the graph is, first we need to draw the graph. So this is the graph. So area under the graph from 0 to 15 means area under the graph up to this, right? So I'll use a different color to highlight. So it is this area what we are talking about, right? Now, what is area under the graph t is equal to 0 to 15? It is, if you name it, say O, A, P, S for scooter, right? So we have area of OABC is equal to distance moved by the scooter. Now, if you observe the figure, what is OABS? Geometrically, this is a rectangle. So this becomes area of rectangle OABC. Now, what is area of rectangle OABC? It is length into breadth. What is length? OS is the length. What is the breadth? BS is the breadth. So what is this equal to? Distance moved by the scooter. Now, measure of OS is 15. Measure of BS is 30. So this can be written as 15 into 30, and therefore distance moved by the scooter is 15 3, which is 450 meter. So we have got two values, distance moved by the car and distance moved by the scooter. Now what is the first part of the question? It is to find the difference between the distances moved in t is equal to 15. Therefore we can say that distance moved by the scooter minus distance moved by the car is equal to 450 meter minus 337.5 meter, which gives us 112.5 meters. Okay, let us come to the options. So there are two options which says 112.5. Now we need to find out the rest, which is time at which the car will catch up with the scooter. Okay, how do we do that? I'll give you a detailed explanation on that too. See, let us assume that the car the car will the car will catch up the scooter after t seconds. So it will catch after t seconds, after 15 seconds. Okay, so it will move till 15 seconds, and after t is equal to 15 seconds, it will move another t seconds, and then it will overtake. Now, what is the condition for overtaking? We know that when overtaking will take place, distance moved by the car, right? Distance moved by the car will be equal to the distance moved by the would be equal to the distance moved by the scooter. Okay, also, some people may have a doubt there also. I'll just give you one graphical understanding about that. See, there were two bodies which were starting from the same position, bodies 1 and 2. One was moving with some velocity, 2 was also moving with some velocity. After a certain time, 1 and 2 were in the same point again, which this is where we say that one has catched up with 2, or one has has started overtaking 2. Okay, so when this has happened, we need to understand that 1 is also moving, 2 is also moving. At the second position, this is the distance moved by 1, and this much is the distance moved by 2. So, when the distance moved by 1 is less than that of 2, the body 1 will stay behind body 2. But when the distance moved by 1 is equal to the distance moved by 2, what can we say? When the distance moved by body 1 is equal to the distance moved by body 2, we can say that both of them have discovered the same distance, or that one has started to overtake 2, or that one has caught up with the body 2. Very similarly, when the car and the scooter has traveled the same distance, we can say that car will catch up with the scooter. Alright. So, what I'm assuming here is this overtaking takes place t seconds after t is equal to 15. So let us assume that this much of time is t. Okay, so the overall duration at which the overtaking takes place is 15 plus t. Now, what is distance moved by the car? Distance moved by the car is area under the curve, right? Area under the curve from where? From 0 to t. Now see, 0 to 2 can be calculated as two halves. One, area under the graph from 0 to 15, and the next area under the graph from 15 to t. Okay, so this will be the distance moved by the scooter while overtaking. Now, what is area under the graph from 0 to 15? See, this is the area under the graph from 0 to 15. How much is that? We already calculated that. What was the value? 112, no, it was 337.5. So that distance is 337.5 meter plus area moved under the graph from 15 to t. See, 15 to t means it is a rectangle. We are talking about this area, right? We're talking about this area. Now, what is area of rectangle? It is length into breadth. What is length here? Length is time, because it is t. What is breadth? Breadth is this much distance, and how much is that? It is 45. So this becomes 45 into t is equal to distance moved by the scooter. Sorry, distance moved by the car. I'm sorry. This is distance moved by the car. Distance moved by the car. Now, again, the explanation repeats the same here. So the overtaking takes place after some time t. Say this is that time t. Okay. So the complete duration of travel is 15 seconds plus t seconds, which means I can rewrite the same notion here. So it is distance moved by the scooter, right? Distance moved by the scooter is what we are trying to calculate, is equal to area under the curve, right? Area under which curve? Area under the VT graph. Now, area under the VT graph from which time? From t is equal to 0 to t is equal to t. So, distance moved by the scooter will be equal to area under the graph from 0 to 15 plus area under the graph from 15 to t, right? Okay, since this is a direct rectangle, we can actually calculate the area directly. How? I'll tell you. See, this is the required area what we are talking about, right? That area is basically a rectangle. Say rectangle O A B S, right? That is area of rectangle OABS, which is equal to length into breadth. What is the length? The length is 15 plus t. What is the breadth? The breadth is 30. So what is area of distance moved by the scooter? It is 450 plus 30t. Okay. Now we're trying to do, what were we trying to do? We were trying to find the time taken to overtake. And what was the condition? The condition was that when they overtake, the distance moved by the car and the distance moved by the scooter will be equal, which means we can equate these two values here, distance moved by the car and that of the scooter. So if we equate it, what do we get? We get 337.5 plus 45t is equal to 450 plus 30t. So 445 minus 30t is 15t. So 15t is equal to 450 minus 337 is 112.5. So we have t is equal to 112.5 divided by 15. So t is equal to cancelled by 5. 5 2s are 10, 20, 5 4s are 20, 5. Wait. 5 2s are 10, 112, 5 2s are 10 again, 25, 225, 225 by 3. So 22.5 by 3. So t is equal to 3, 7 3s are 21, 15, 7.5. So t, the value of t is 7.5. Now, what did we say? We said that, what did we assume? We assume that the overtaking is done after t is equal to 15 by moving through a gap when the body is moving through t seconds. So we have 15 plus t, which is 7.5. So it is 22.5, which means the overtaking will take place after 22.5 seconds, which gives us the answer to be 22.5 seconds, option D.